Okay, so welcome to our first functional group that we'll look at, first homologous series, the alkanes in Level 2 NCEA Chemistry selected organic compounds. So the alkanes, the class name, of course, as you can see, is the alkanes. The general formula is CnH2n plus 2, so there's always an excess of hydrogens. The functional group name is the alkyls. There is actually no functional group, but if there was, I guess I'd say it's the carbon-hydrogen single bond. And the suffix that we use is ANE, the anes. So these are the first six alkanes. Okay, so methane, because meth is going to be the prefix for one carbon. Ethane, because eth is the prefix for two carbons. Propane, pro is the prefix for three carbons. Butane for four. Again, butane is, or bute is the prefix for four carbons in a row. Pentane is for the five carbons, because pent is the prefix for five carbons. Hexane is hex, okay, and it's six carbon alkane chain. And the other ones that you might have to know are the heptane, so hept is for seven, and octane, okay, like an octopus. Oct is the prefix for eight carbon chains. You also have to be aware of alkyl groups, and the two major ones are the CH3, which is the methyl group, and the C3H2CH2 group, which is the ethyl group. Okay, so that's also required when we do the following, when we're looking at naming branched alkanes. Okay, so for naming branched alkanes, which are a little bit more complex than naming the straight chain alkanes, you count the number of carbons in the longest chain. You name each attached group, so that would be the example of the methyl and the ethyl. Then you count the longest carbon chain to give the first attached group the smallest number. And finally, name and locate each group. Okay, so here's the example here. So in terms of naming this branched alkane, the longest chain is 1, 2, 3, 4, 5, 6 in length. The methyl branch is on the third carbon. Okay, so it's 3-methyl hexane, because a 6-carbon alkane is known as hexane. So in terms of cyclic alkanes, which are pretty rare but still, they basically have a closed loop structure. Okay, so there's no straight chain alkane in that sense. They have a different general formula, so it'll be CnH2n. But basically, they are named by counting the number of carbons and of that given alkane. So 3 carbons would be propane, for example. So then you just put the cyclo prefix in front. So C3H6 would become cyclopropane. Okay, and in terms of the melting and boiling points of the alkanes as a homologous series, the general trend you see is an increase in both melting points and boiling points. And this is because as the number of carbons increases on that chain, what's going to happen is there's going to be more interaction, more intermolecular bonding between those two carbon chains, which means more energy is required to break that intermolecular bonding. Therefore, more energy is required to change it from a particular, say, from a solid to a liquid to a gas, to break those changes of state. Because remember, in changes of state, it's the intermolecular bonds that are breaking, not the intramolecular bonds. Okay, when I say intermolecular bonds, it's the bonds between the molecules. Intramolecular bonds are the bonds inside the individual molecules. Okay, that's the reason why the melting and boiling point increases as the number of carbons increases, as you can see actually from the graph on this slide. Okay, so that's the alkanes. Our next class of compound is going to be the alkenes.